All right, we left off the last hour having run our first test, and I ran it with copies. So copies is not what I wanted. So let's delete those copies. Select our top level group, choose instance, and go with the same degree amount. I think I'm going to go with this overlap. After taking a close look at the reference, I can see that these banisters do in fact hug those edges really close. So I'm going to go with it. And the base of the banister seems to be fair, and I've got plenty of room to build my own banisters. So I'm going to go with this. So again, step group is selected, and I've got my stats set up already solved. Instantiation, 23 units up. Rotate pivot on the y-axis, 27.69. 12 more copies. I've got one, so for a total of 13. And before I did any of that, I made sure that the local rotate pivot was set to 0, 0 on the x-axis on both rotate pivot and scale pivot. And it should read zeros all across translate, rotate, and scale should be 1, 1, 1. And the only value that should be different is that it went straight down, -18, if you've been following me exactly. Great, so with that selected, hitting apply. Boom, instances. And that went way faster than when I made the copies. Really nice. Great, so when we make changes, if we decide something is too big or too small, we can make changes at any one of these, and tagging vertices, moving things, scaling things. I'm pretty happy with what I've got. I'm going to focus on the banister next. Let's start the banister with this cylinder that we've added to the scene and name it. In the reference, there's five vertical banisters per step. We're not going to do that yet. We're going to make one per step. And we're going to use that one per step to produce a nice, smooth, swirling handrail all the way up. And then we're going to produce that handrail. Then we're going to produce the remaining banisters to match that handrail, because I want to be able to get a nice, clean curve all the way up, and the only way I know I can get that clean curve is by having one point to snap to per banister. So here's how it's going to work. I'm going to come over here, and we're going to put the banister, snap it to, say, this vertex right here on the edge, just hugging the edge right there, just like the reference shows us. Going back to reference, how tall do you think one of these banisters are? Now, they're all the same height, or are they, right? Are they all the same height? No, not really. So this one here on the inside is shorter than the other three. They get longer, right? So this shortest one, look at how many steps it is. Was that 1, 2, maybe it's 3 steps tall? Maybe. Whatever the height is, we want to make a decision and then stick with it. So I'm going to say it's probably at least 3 steps height's worth. So that's going to be about 69 centimeters. Let's make it 70 centimeters flat. So going to the polycylinder tab in the attribute editor for height, set it to 70. Next, move its pivot point to snap to the bottom of the cylinder at the center. Then snap it to that same point. Great, so that's how tall the banister is going to be all the way up. Group this banister. So now it's got a group at the same center on the at the origin as our step. Name that group. Now instantiate this group with exactly the same settings. It goes all the way up. Look at that. Okay, now take the top vertex, the very top vertex of this banister, and just pull it up. Turn off the slide. Don't need surface sliding. Pull that up, so it's just pointing up, just like that. Okay, now we're going to use that to snap a curve to. Go get your create, or just get your EP curve tool. Choose your EP curve tool. Go ahead, turn on point snapping. Just make sure it's on all the time. And then just click, rotate the camera, click, and so forth. all the way up. Okay, once you've completed, take another minute and confirm that you actually have each edit point at the top point of each banister. Okay, once confirmed, take a look at your reference again. Notice that the handrail is just slightly longer than where the banister connects. Most likely true at the top as well. So let's extend this curve. Curves, extend curve, option box, both ends, at least a unit, have to be longer than that. Yeah, definitely longer than that. Let's undo that move. Let's make it 10 units. Okay, good. Yeah, just a little bit there. And if we need to nip it off when we get to polygons, we can cut a little bit off at polygons. Okay, also go back to your reference. Notice it's not a round rail. It's got a bit of a square shape to it. Maybe the top is rounded, but the bottom is more square-like. And the front end is more square-like. Definitely the top is rounded. So the profile looks like that. So that's most likely what the profile looks like. Awesome drawing, right? So we can't just put a square curve along this path. We saw that earlier. At least I think we saw that earlier. Believe me, if I use a square profile and extrude it along this path, it will twist all the way up. So it doesn't work very well. What works better is a loft. So if we take this curve and we make a duplicate of it, and we move that duplicate straight up on the y-axis, so I'm just control-clicking here on the y-axis in the attribute editor, clicking and dragging, we can then loft between these two pieces. And then that becomes a ribbon. And then from that ribbon, I can create a polygon object and make any of the final changes I need from there. All right, let's convert it. Open this up. Use general, quads, per surface number of isoprons for U and V. And then we want to have a lot running along the length of it and only like 2 or 3 running, well, a lot running cross sections and only 2 or 3 running the length of it. So that would be 100. Let's do by 4. And, well, that did not work out quite the way I wanted it to, so let me look into this. It looks like per surface number of isoprons in 3D worked out better. I've got a better distribution of edges, and that's ultimately what I'm after. So go ahead and switch that to the first entry for U-type, V-type. And 104 seems to work out good. You could probably get away with even 2 on the V number, because we don't need a lot of divisions on that, not yet. Select a lofted surface. Don't delete it or anything of this sort. Just place it on that layer that has surfaces. Say add selected objects, and it will hide because that layer is hidden. And then let's thicken this wood, strip that's going to become the wood. So that would be Control E. Don't need that right now. And let's thicken it. Let's go with 1 unit for 1 centimeter. Take a look at reference. Just how thick do you think that is? 3 maybe at the most? 4 at the most? It's definitely thicker than the tops of the steps, and we had that at 2 units. So maybe 2. Maybe a maximum of 4. Okay? And then select the inside. The inside. Hold Shift, double click. Yes. Get the inside and extrude that. Extrude that one. And thicken that one. Also 2 units. So you have a total width of 4. And notice how that has the correct twist all the way up. It's really quite pretty. And now we can do detail work at the ends on the corners and make sure we don't have any crashing polygons and sorts, weird things like that. Tap number 3 and just confirm that it doesn't have any really weird glitchy stuff going on. It looks pretty good. Looks really good. And as for the square bottom but round top profile we talked about, that could be as simple as taking this one edge loop and moving it up, but I think I need at least 2. Let's get 2. Or, no, let's use this 1 and then use edge flow. Maybe edge flow to help do the rest. And then translate that edge straight up. So let's go to the front view, frame it, and translate that up. Turn off snapping. Take a look at that in profile. You can see it looks like a little house profile. And then what if we used edge flow here? Control middle click. Yeah, but it does some problems. It causes some problems on the bottom. So that might be bad unless we delete the ends. Delete the ends like that. Delete the ends at the top. Delete the ends at the top. And while you're here, go ahead and take out these edge loops. They're just kind of clustering up there. Now do the edge flow. And you can see it doesn't mess up the bottom now. And we get that nice shape. Good. And if you feel like you're losing proportions, like it's not thick enough, it's not wide enough now because it's too tall and you lost your proportions, go back to your poly extrudes. Actually, just tap T, then go to your poly extrudes, and then just change thickness here and here. And now it feels like we've got proportions back. That does feel a lot better. Three on each side. Apply the same material that the wood has. Cap the ends and then do bevel work. Go ahead and extrude and multi-cut the ends so that you have this pattern. Do the same thing on the other side. I have made this selection for the bevel, where I've selected the outer edges of the ends and only the two lower edges along the bottom, and the remaining edges are ignored. And I'll run the bevel. I'll add one more supporting edge loop up here at the top using multicut without edge flow, just to help even out the spacing. Just that top end there was a little weird. And you might want one down here too. Go ahead and turn on soften edge for it, but ultimately I will probably use subdivision surfaces with this object. And here it is without the wireframe. So it looks pretty clean. All the way up, looking pretty good. Okay, next up is to match banister for 5 of them. Match banister along the changing heights from step to rail. Okay, my objective here is to make one good clean set of 5 and then reuse that set of 5 with instantiation. Looking at this from the top, you can see that the one end of my handrail doesn't quite match the shape of the step. You can see it's just a little bit off, right? Whereas it seems pretty good the rest of the way, although it seems like I got something cut off here, but it seems like it's okay. Why don't we take one look at, say, this and do Shift-I. Look at it from the top. Yeah, it's still clipping. But I think it's clear enough that if I were to use Shift-I, if I were to match, say, this and that, Shift-I from the top view, I'm probably not going to have a good starting setup. So I need to make this match this shape better. So I'm going to do a bit of modeling using soft selections. Okay, I feel I got that pretty close. And then I'm going to spend time matching the foot of this one to the body down here. So I'm going to spend time sculpting this shape. Again, looking at reference, just looking at the shape of the foot down here. And this is standard cylindrical modeling stuff that we've done many times before, so I don't think I need to record this. Okay, so I took some time to do a little bit of modeling and to change the shape and looking at reference for inspiration. Nothing new there. Now, matching to this surface is a little bit different. But I don't intend to actually cut holes. I don't intend to actually create the hardware. I just want them to be sitting on top of each other. So first I'll begin by taking polygons and moving them into the surface. And then I'll use multi-cut to slice at that angle. If it'll let me. I'm going to delete construction history for this object, and I'm also going to remove all other instances. Okay, so it's all by itself. And I'm going to make this cut in the 3D view. So I'm just going to kind of rotate the camera until I kind of get to that right angle, then perform the cut. There it is. Got it. Switch back to the right-hand view. Back to faces. Delete those. Take these faces, just tuck them up just ever so slightly, so they're just tucked right there into the surface. Cap the end, full hole, and then bevel work. So I can clearly see this little metal tab sticking out, go pointing in that direction, and each one has it. That's most likely where it screwed the banister to the handrail. And it's always the little details that just really improve the piece. You know, before I go on to putting that little tab in there, I noticed that these pieces are twisted at a second look. So I decided I wanted to add that. So up here, I removed a bunch of edges. So I have this straight part right here. Then I'm going to use Insert Edge Loop Tool option box and add many edges. And then maybe divide those even further. It takes quite a bit of this to do a twist. Then select the area you want to twist. Say right there. And then come to Deform, Nonlinear, Twist, and set an angle 360, and if you want to do anything more, you can tweak these numbers, but that's pretty good. That's pretty much what I wanted. Oh yeah, and one more thing. If you want to, you could take the time to select an edge loop's worth through the twist. So you can see if I just double click that edge loop. So from here to here would be the twist, right? So if I go from there to there, double click, shift double click. Okay, I finally got it. I had the wrong one. So select the range. You can bevel them. So you could do one at a time or take the time to select all of them and bevel them, and that would actually accent that little peak on the twist. Another option, other than the bevel, because the bevel will create end guns that you'll have to clean up. Another option is that you could take the same edge loop and simply transform it on the local Z, and by doing that, you accent its neighbors. So you can create, deeper peaks and valleys. So you could do, every other edge loop, accenting it. See, so a little bit more change to the form there. So you have options. Play with it. All right, I finished the twist, and I'm ready to add that little metal tab at the top of the banister. I think the way I want to do this is to use the edges to guide me on fitting it exactly against the surface there. Just a little broad, flat box that sits up there that I could connect the banister to. And I'll add edges to the handrail for this process, then take those edges out when I'm done with this process. And I'll make sure that my edge flow is off when I do this. So it looks like from the illustration, from the photograph, that they probably come forward 2 to 3 centimeters or more. So I would say they stick out about that far, and then I need them to split. Yeah, right about there. I need it to come to the back end. Yeah, right about there. So I'm just adding a bunch of edge loops here so that I could help mark out where I'm going to extract that box. So from here, I will take, holding tab, I will take this selection. That seems to be a good selection. And because, you know what, because we're instantiating this stuff, it doesn't really matter if I get the exact length correct right now, because once I see all 5 sitting next to each other, then from there I can make adjustments, and then as we instantiate all the way up, everything will be spaced out nicely. So as long as I get these 5 evenly spaced, everything else will look good. So with that selection, duplicate faces using face duplicate. Open the outliner with your cursor over the outliner, tap F to find it, and that should be the object right there. Shift P and delete construction history. Remove the edges that we had added to the handrail. You can use quad draw to do that. Just hold Shift Control and then make sure your cursor is over the edge. It's pretty quick. Put the handrail on its own layer and reference that layer. Select these few polygons you have here and thicken them. I think 1/2 centimeter should be enough. If these 2 back polygons here are clipping your cylinder like mine is, go ahead and move those according to component. Just slide those down so that we have a better intersection between the banister and this metal piece. Also make it a little bit more narrow. Just scale those pieces towards each other. Make sure you're scaling via component if it'll let you. That's really not gonna work, is it? It's because it's not a true square object. Go ahead and just translate those in one at a time. And then while we're at it, let's simplify it. Using the quad draw tool, hold Shift and Control, click edges to remove them. There. There we go. I'm just changing the length slightly, bouncing between reference and the object. Make sure you're actually against the surface. So I'll select the polygon instead of the points and just tuck that ever so slightly to the surface. Okay, now I'll add edges in order to perform a connection. I'll make sure that the vertices of the banister cylinder are inside the box. Make enough cuts to support connections after a Boolean. And if you don't want to do a Boolean, we could also do where we just cut out these few polygons. We could do that as well, right there. And make sure you have one more edge on the back end, separating it from the corner. We definitely need one right there to help separate from the corner. Delete construction history of both pieces and perform a Boolean, or use any of the other connection methods we know. Clean up the Boolean. Once you've cleaned up the Boolean, go ahead, apply a material, and bevel remaining corners on the box. I'm going to take this supporting edge out that I placed in earlier, and I'm going to bevel the remaining corners of the box. add in a few supporting edges for textures and possibly for in future date to add in, a screw head or something of that sort. Go ahead and just kind of block it out a little bit, and that'll make the whole painting process or adding details further easier down the road. And that should be more than enough, and that will support subdivision surfaces cleanly. Go ahead, double check your work with subdivision surfaces turned on, and just spin it around and make sure everything came out good. Okay, so now my job is to reuse what we've done here. Alright, next we're going to make 4 more of this object, and let's confirm where our pivot point is for this object. The pivot point is not in the right place. So I'm going to move it to the bottom side of the banister. Use my layers to hide the step, and then snap pivot point to the lowest point on my banister. Unhide the steps, turn on the wireframe, and determine what the spacing should be in creating the additional 4. I think it's pretty easy. It's going to be 1, 2, 3, 4, and that's just complete luck that I had just the right amount of edges to support 5 banisters. Just complete dumb luck. Okay, but that's fine. I like luck. So duplicate. Don't instantiate. Duplicate, because this one's going to be different. And then translate snap to that point. Same thing. Duplicate, translate, snap. Duplicate, translate, snap. Until you have them all. And then the last one should pierce through the first one. So it's actually going to be a little bit different. It's going to connect on the bottom and then connect at the step as well as connect at the banister. Looking at the reference, I was wondering, is the twist at the same level per step? Could I just, tag some vertices here and just move that up? And looking at the reference, I can see, no, it's actually kind of random, isn't it? There doesn't seem to be much of a pattern to it at all. They just put one in there that fit that length, and they don't seem to hold to a pattern. Unless you're seeing a pattern. Are you seeing a pattern? I don't really think it matters. I think we can make our own pattern. So let's pop back over to, where'd it go? Maya. And let's start with this second one here. And tag vertices. Let's get out of subdivision surfaces, by the way. Okay, good. And tag vertices, and just move those straight up and see where do we hit. Where do we hit? So I'm expecting that we'll have to turn it or twist it, not twist it, but rotate it a little bit. I'm expecting, that we'll have to do it on the y-axis just a wee bit. Maybe, maybe not. Take some time and move those all up there and see how they hit the handrail. Yeah, so here I've moved the third one up, and you can see that it's slight angle. It's not touching on one end. So here I've got the attribute editor open, and here it is at 0 degrees rotation. So if I rotate this just by control clicking and dragging, nice small changes. You see how it kind of evens it out. So there's an even space. So just a small amount of turning on the y-axis. So I was thinking that these are going to rotate, right? Just a little bit each time we go up each step, right? So there's essentially 4 new ones per step, because I start with 1, right? 1, 2, 3, 4, and then 1, 2, 3, 4, and then 1, 2, 3, 4, right? So 4 more per step. So 4 times, what, 13 steps? Okay, so that's 52 banisters. So what, 360 divided by 52? 6.92 degrees. That's a good thought, but 6.92 degrees seems way too strong. You can see that it's way over twisted, even on the second banister. So if we just crank that back, it looks like it's not even a degree of change. and it seems to match pretty good. In fact, if you compare that to the first match, you can see how the first match intersects very nicely, very even, and then the second one doesn't evenly match nearly as well. So we could do a little bit of tipping or tilting of the vertices at the very, very top. So I've made that selection and just of the vertices themselves and just tip it ever so slightly. And that seems to fit better. So I think as long as we can set up these 5 manually and manually fit the connections to the bottom of the step here and fit to the top of the wood here, I think we'll be good to go with instantiating the rest all the way up. And then we'll just go through each one confirming. So I'm going to take a little time to move these up, make these fine adjustments, and then I'll be back. All right, for this banister that needs to connect at the bottom and connect at the wood, I don't want it to be 2 pieces. I want this to be one banister, but I also don't want to deal with punching a hole through here. I just want it to rest in there and look as if it was maybe screwed in from the bottom. So to achieve this, I'm going to first insert an edge loop at about where it looks like it connects. And same thing down here. Okay, I already have an edge there, that's good. Then I'm going to delete polygons, excuse me. Let's set our steps to reference so I can't select those. I'm going to delete these polygons. Yes, there we go. Cap the ends, and then do bevel work and just do work around it like I had done on the foot here in order to give it the impression of being connected, and that's it. Right, just hide the steps to make it a little easier. Select n-gons, poke faces, and so on and so forth. We are dealing with an 8-sided cylinder here, so take the time to remove every other edge. Yeah. That should be good. So when the time comes, if the time comes when you have to smooth it, everything will be quadrilaterals. I should have done that the first time. So I do like to have a little bit of clipping. I think I've made that clear before, but in this situation, just a little bit of clipping does pay off. It helps to cement that 2 things are together. And since I'm not using any sophisticated deformers, what am I doing here? The best choice, I was just trying to get to the right-hand view. The best choice is to do a tiny amount of clipping. So I'm just looking at it without wireframe, looking at it with sub Ds, and see, does everything fit together and look solid? Looks pretty good. Before continuing with the instantiation, do a couple of basic things to help make your next steps cleaner and easier and less complicated. Okay, first, delete construction histories for all of those objects. Name all of these objects. And, they're all really the same object, so just go here to rename and just enter the name Banister with an underscore, and then Maya will automatically number it. And you could give it a starting number of 0, Banister underscore 0, and then hit return, and it'll number them 0, 1, 2, 3, 4. While you're here, unparent the handrail and name it as well, if you haven't done so already. Place the curves we used to create the handrail with. Place those curves onto a layer and just move that layer down with all the others and set it to reference and hidden, just in case we need it. So we'll just put it down there hidden. All right, it's time to instantiate the banisters. Select all 5 and group it. Name that group. Take the first one out of this group, actually. Shift P. We don't need the very first one. We only need those 4. Now, go to Duplicate Special Option box, and let's do this a little bit differently. Choose the Copy option, and then Instance Leaf Node. Same stats on the transforms, and hit Apply. And then confirm your work. Now, if you need any of these to be different, individual, or unique, you can convert them using the instance to object conversion. Okay, and we could extend our curve. We could, or even just extrude our remaining handrail all the way up here. Looks pretty nice. Great. Now you have the ability to go in per vertex in each instanced object and make changes if you want to. So if you want to change the height or position of the twist and you want to go through and adjust that, maybe make it more smooth or make it more irregular, now it should be pretty easy and still keep to a pattern. Turns out I could still use that curve, or at least some part of those curves that we created for the handrail. I wish I'd had the foresight of coming all the way to the second floor. But I did not, and I refused to go back, as well as you should too. You should refuse to go back. And let's plow forward and make a fix from here so that we can get that handrail to go all the way up. And one of my concerns is that the handrail is pointing in this direction, and I want it to arc further that direction. So we're going to have to do a little bit of modeling to get that correct arc, correct angle. Also, the last one is the one that was split. That could either be the second floor, but I don't think this is the second floor. Our 13th step was supposed to be the second floor. So we can remove this one and use another copy of the very first one down here, another instance version of the very first one down here. Maybe not an instance version, maybe just a duplicate and bring it up here. Yeah, I think a duplicate would be best. So I'll delete that one to start. Actually, no, don't delete it yet. Bring a duplicate of the very first one up there and get it in exactly the same place, match the height, then delete the other one. Yeah, this is good. So I just snapped it into place, and now we'll just match more or less where it is. Rotate it on the y-axis. And maybe do just a slight rotation of component, although we might change our minds. Let me shrink the selection. We might change our minds on how much rotation this is when we get the remaining banister in here, or the remaining handrail in here. Okay, so that's in place, so we can remove this very last banister that has the split for the step. And now you see the reason why I chose to do copy with instance leaf node. If we had not done that, I would not be able to delete this individually. Unless, of course, I convert it to object, but it's just as easy. Now I can delete that one and find my solution for continuing the handrail. Okay, so to extend this, we're going to first extend the curve itself, and I'm not going to use the original one. I'm going to use the second one, the one we use for lofting. And then we'll do an extrusion of polygons along a curve. We haven't done that very much. I haven't stressed it much, but that is a very simple solution for this problem. So first, let's take a duplicate of this curve so that I'm not hurting it whatsoever. And let's not use Control D because that's running one of my scripts, which would duplicate everything associated to the curve. So let's use this duplicate right here so that we only get the curve. Okay, then we're going to use this curve to extend it. Let's hide the old curves, and this curve is automatically added to that same layer. Right click on that, darn it. Right click on that layer and choose remove selected object so that we can see that curve. Okay, so now we're not going to hurt the original two curves. We've got a new curve. Let's extend this curve. Let's extend it at the end only. Make sure end is checked, and let's extend it at least 20 units. Okay, and then let's see what we get. We get a few CVs. Let's then select a curve point right near where it intersects with the polygons and detach. Yeah, detach curve. And that will build a new curve from it. So we should just have a little tiny piece of curve. Good. Go to Control Vertices for that new curve and model it to follow the flow of our banister. I've switched to the top view. I've selected the 4 banisters in the curve, and I hit Shift-I, isolating it from everything else. I am not going to point snap it. I'm simply going to move it into place and then adjust it from the various views until I believe I've got the right height. Don't worry about having the perfect curvature on this curve. Just concern yourself with getting it approximately where you think it should be, because we can always adjust the CVs even after the extrusion. So let's prep our area here by removing an edge loop. Actually, let's just remove the entire end of the handrail. Just grow that selection and cut the whole thing off. Okay, then fill it. Fill. Then select that polygon. Select the curve. The curve should be highlighted in green. So okay, let me say that again. Select the polygon, Shift select the curve. The curve should be in green. If it's blue, you did it wrong. Just try again. Make sure that the curve is in object mode before beginning this. So polygon, Shift select, and then run a normal extrusion. It's the same extrude tool. See? And it's going to be a straight line. It will be a straight line. So add divisions, and it will curve out. And you'll see how well we've crafted it based on how well it, and you can see that we need a little bit more work on that curve. Okay, after performing the extrusion, you can see there's still some things that need to be done. First thing I'm thinking is remove this edge loop to help sort that out. Then go to wireframe, select the CV of the curve underneath, and move it down. Move it down so that it touches the handrail. So we don't need to, not the handrail, I meant the banister. So we don't need it to move the banisters. What we need to do is move the handrail until it intersects the banisters. Good. And then we'll have a twist. We'll have a twist in the curve, so we'll have to counter twist that. You can see that it's not quite twisted at the correct angle. In general, the first CV should be leading it straight out of the, I'm sorry, the second CV should be leading straight away from the first CV. So if you mess this first one up, it can get really cranked up, really messed up. So try to work on that one first, get an overall feel for it, then go through manipulating the others. Then I'm going to go back to faces on the handrail, soft selections on the handrail, grow my selection, holding B, growing my selection, capturing all of it. And my soft selection is set to surface, surface, and then twist it, rotate it, like that. That's a little bit better. And then overall it seems like it's the wrong size. Like you see how each edge is leaning forward on the original one? So we can lean each one forward. In fact, I think what would be better at this point is don't lean each one of these edges forward. In fact, let's just take them out, right? And let's go with super simple, like one edge loop per handrail, like that. Get it a good feel here, then use the multi-cut with or without edge, probably without edge flow, and use the multi-cut to add in the remaining sections. Yeah, so just lean that edge forward, which will change the volume of it, and then push it down. And now that seems to be more correct, more like the volume that the handrail has. It's really hard to do it this way. So, but I don't want to go all the way back. At least I don't think I want to go all the way back. Okay, I got it pretty close, and I'm pretty happy with that. I could be happier. If I wanted to be perfectly happy with it, I would rebuild the entire handrail again. But I want to move forward. Proceed with finishing the ends like we did before, extruding it, offsetting it, and multi-cut. And it's a little different this time because I've got a bevel on the corner, so don't pull that extrusion in so hard, so far. Okay, that end is done.